We'll be looking today at electrocution injuries, okay, or electrical injuries. Now let's look at some basics of electrocution. We know that there are two major effects of electricity on body. These are cellular depolarization and of course your heat production. So electricity causes cellular depolarization, not repolarization, depolarization and heat production also. Now, what we have to understand here is AC, that is alternating current, is 4 to 5 times more dangerous than DC or direct current. So, AC is more dangerous. Direct current injuries are uncommon. They are usually seen only while there is a lightning strike or there is a contact with certain equipment that use direct current. Okay, these are rare. Okay. Now, the Ampere determines the fatality and causes Tetanoid convulsions. The Ampere, that is the power of the current that which is hitting the body, determines its fatality and it also results in tetanoid convulsions. Now, electrocution is rare at a voltage less than 100 volts and most deaths occur above 200 volts. So, for death to occur with electricity, the voltage should be above 200 volts. Okay. Now, resistance, we have to understand it is directly proportional to the amount of burns. Greater the resistance, more likely that the burns will result. Okay, resistance is directly proportional to burns. Now, dry skin, please make a note, it's a very interesting point over here, offers high resistance. That is about 1000 to 1500 ohms of resistance is offered by dry skin. Blood has low resistance. So, because electricity tends to be conducted via the blood vessels, it has low resistance. However, with higher voltages, there is no use of dry skin or moist skin and skin has no significant role to play in protecting you, right? Now, the individual tissue with maximum resistance to electricity in the body is bone. Bone has maximum electrical resistance. In body, maximum resistance is seen, we have seen in dry skin and bone is more resistant than obviously your moist skin. What is the cause of the death in electrocution? Obviously, because there is variation in cellular voltages, it results in cardiac arrhythmia, which is the most common cause of death. Also, there is respiratory failure. Then, there is a dangerous circuit formation from right arm to left feet. This also results in death. The dangerous circuit is from right arm to left feet. Now, we have to know that there are three types of electrical burns. The first one is contact burn, number 2 spark burn, number 3 flash burn. Contact burn, spark burn, flash burn. So what is this contact burn? It occurs due to contact with a live wire. You go and touch a live wire, you're going to get burnt. This is known as contact burn. When you talk about spark burn, it is due to sparking of current like in a loose electrical fitting. There are sparks occurring from a loose electrical wire. We all have seen that, right? So that results in spark burn. What is flash burn? It is current from the main power lines. These are the huge power lines which transmit current. These results in flash burn. Now, we have to understand what are the postmortem findings in electrocution. We will start off by looking at the skin findings, muscle findings and bone findings. Let's look at the skin findings. What we are looking at in this picture is known as a jowl burn, right? It is also known as an endogenous burn. As you can see, it is a central crater with elevated margins. You can make out in this picture, right? Central crater with peripherally raised margins. It is due to low voltage, but there is a tight contact, right? There is a nuclear streaming or palisade appearance and epidermal separation occurs due to microblisters or vacuolation, and also there is coagulation necrosis. These all are features of endogenous burn or jowl burn. It is due to low voltage but tight contact with the source of electricity. So the second effect we are looking at is metallization. It's nothing but the deposition of metallic ions from the conductor of the electricity into the skin. You can see all these markings over here, right? This is metallization of the skin. These are the metallic ions of the container which is transmitting the electricity. That's the conductor. It transfers its metallic ions into the skin. Okay. Now, acro reaction test, please remember for your exam, it detects metallization. Acro reaction, metallization. Acro reaction, metallization. Okay. Now, the third one we are looking at is the current pulse. These are when these metallic ions go and deposit straight away in the tissues. This we are calling it as the current pulse, right? So the fourth one we're looking at is the high voltage or loose contact skin. It results in crocodile burns or flash burns. So what are these crocodile burns? These are multiple pitted lesions, whereas flash burns are diffuse patchy lesions. Let's look at these. So this is how the crocodile burn appears, multiple pitted areas, and this is the flash burn. Now, what are the muscular findings? The most important one is the Zenker's degeneration. What is this Zenker degeneration? It is caused by the passage of electricity to the muscle, resulting in myolysis and myoglobinuria. There is myolysis and myoglobinuria due to electricity. This is known as Zenker's degeneration. Now, what happens to the bones? There is a bone pearl or wax dripping. See, you can see at the margin of this bone that as if some wax is dripping along its periphery, right? This is known as wax dripping or bone pearl. This is seen in high voltage electricity is passing through the muscle, right? Now let's look at our final topic, that is filigree burns. Always it is seen with lightning. Lightning causes filigree burns. Okay, filigree has Li. Li is for lightning. Please remember like that. These are arborescent marks. Arborescent means tree-like, right? So the marks look like a branch of a leaf or the branch of a tree. See, you can see it's looking like a tree, right? It is also known as Lichtenberg flowers or keranographic marking. Okay, keranographic marking or Lichtenberg's flowers. It is seen from 4 hours to 48 hours after the lightning has struck. It's not an immediate finding. You can see it after 4 to 48 hours. However, the clear mechanism for this beautiful tree-like pattern is unknown. There are some theories. You just have to remember the names of these theories. These are the static electric discharge theory, the hemoglobin staining theory, and the electron showers. These are the theories